What if everything you thought you knew about the universe was wrong? Picture this: a vast, endless expanse filled with mysteries that defy logic, where the rules of reality seem to bend and break. From the moment we first looked up at the stars, humanity has been captivated by the unknown, and yet the more we discover, the more questions we uncover. Today, we're diving into the 30 most terrifying space theories that will challenge everything you believe about the cosmos. These aren't just ideas, they're mind-bending possibilities that could rewrite our understanding of existence itself. Theories so unsettling, they'll leave you questioning the very fabric of reality. Are we alone in the universe? Is time running out? Could everything we know be an illusion? Stay with us, because by the end of this video, you'll see the universe in a way you never have before. Let's begin this journey into the unknown, where the truth is stranger than fiction, and the mysteries of space will leave you in awe and maybe a little terrified. Now, turning to the first of these mind-bending theories, let's explore the Big Crunch. Imagine the universe as we know it, expanding, stretching, and growing for billions of years. But what if this expansion isn't infinite? What if one day it all comes crashing back together? This is the essence of the Big Crunch theory. Scientists propose that the universe, after reaching its maximum expansion, could begin to collapse under the force of gravity. Galaxies, stars, and even atoms would be pulled back into a single, unimaginably dense point, a singularity. This would mark the end of time and space as we know it. The implications are staggering. If the Big Crunch were to occur, it wouldn't just mean the end of planets and stars, it would mean the end of everything. Time itself would cease to exist, and the universe would return to the state it was in before the Big Bang. But here's where it gets even more unsettling. Scientists are divided on whether this theory holds weight. Some argue that the universe's expansion is accelerating, making a collapse unlikely. Others suggest that dark energy, the mysterious force driving this acceleration, could eventually weaken, allowing gravity to take over. The Big Crunch forces us to confront the fragility of existence. If the universe can collapse, what does that mean for our place within it? Are we just temporary inhabitants of a cosmic cycle that will eventually reset? These questions don't just challenge our understanding of the cosmos, they force us to grapple with the very nature of reality. And as we move forward, the next theory will take us even deeper into the unknown, where the universe's fate becomes even more chilling. Now, turning to the next chilling theory, let's delve into the heat death of the universe. While the Big Crunch suggests a dramatic collapse, this theory paints a far colder and more desolate picture. Imagine a universe where all energy is evenly spread out, where stars have burned out, galaxies have faded, and nothing moves or changes. This is the heat death, a state of maximum entropy where the universe becomes a vast, lifeless void. Entropy, the measure of disorder in a system, is the driving force behind this theory. Over time, energy naturally spreads out and usable energy becomes scarce. Stars exhaust their fuel, black holes evaporate, and even the smallest particles decay. Eventually, the universe reaches a state where no work can be done, no heat can be transferred, and no life can exist. It's not a fiery explosion or a dramatic collapse, it's a slow, inevitable fade into darkness. What makes this theory so unsettling is its inevitability. Unlike the Big Crunch, which depends on the balance of forces like gravity and dark energy, the heat death is rooted in the fundamental laws of physics. It's not a question of if, but when. And when it happens, the universe will become a cold, unchanging expanse, devoid of light, warmth, or any semblance of life. The contrast between the heat death and the Big Crunch is stark. One is a fiery, dramatic end, while the other is a silent, eternal freeze. Yet both force us to confront the same terrifying truth: the universe as we know it is not eternal. Whether it collapses or fades, the end is inevitable. And as we ponder this, the next theory will take us even further into the unknown, where the mysteries of the cosmos grow even more profound. Now turning to the next mind-bending theory, let's explore the Fermi Paradox. Given the sheer size of the universe, with its billions of galaxies and trillions of stars, it seems almost impossible that we haven't encountered any signs of extraterrestrial life. This paradox, named after physicist Enrico Fermi, asks a haunting question: where is everyone? If the universe is so vast and ancient, why does it feel so empty? One terrifying explanation is that advanced civilizations might self-destruct before they can make contact with others. Imagine a species reaching the peak of technological advancement, only to destroy itself through war, environmental collapse, or some other catastrophic event. This idea suggests that the universe might be littered with the remnants of civilizations that never made it past their own self-imposed limits. Could humanity be heading down the same path? Another chilling possibility is that we are being deliberately avoided. Advanced civilizations might see us as too primitive or too dangerous to engage with. Or perhaps they are hiding, fearing that any contact could lead to their own destruction. This concept, known as the dark forest hypothesis, paints a universe where silence is survival and any sign of life is met with suspicion or hostility. The implications of the Fermi paradox are profound. If we are alone, it raises questions about the rarity of life and the uniqueness of our existence. If we are not alone, it forces us to confront the possibility that the universe is far more dangerous than we imagine. Either way, the paradox challenges our understanding of our place in the cosmos and forces us to consider the fragility of our future. As we grapple with these unsettling ideas, the next theory will take us even deeper into the mysteries of the universe, where the boundaries of reality itself begin to blur. Now turning to the next unsettling theory, let's delve into the Great Filter. This concept suggests that there is a critical barrier or filter that prevents civilizations from advancing to the point of interstellar travel and long-term survival. The terrifying implication is that humanity might be approaching this filter, and our future could hinge on whether we can overcome it. One potential filter is the threat of nuclear war. Imagine a civilization on the brink of technological advancement, only to destroy itself in a catastrophic conflict. The development of weapons of mass destruction could be a test that many civilizations fail, leaving behind only silence in the cosmos. Could humanity's ability to avoid nuclear annihilation determine whether we pass this filter? Another possible filter is climate change. As civilizations industrialize and consume resources, they risk destabilizing their own environments. The consequences of unchecked climate change, rising temperatures, extreme weather, and resource scarcity could lead to societal collapse. This raises the chilling possibility that many civilizations might thrive for a time, only to be undone by their own impact on their planet. Pandemics also present a potential filter. A highly advanced civilization might develop the means to cure diseases, but what if a new, unstoppable pathogen emerges? The rapid spread of a deadly virus could wipe out entire populations before they have a chance to recover. This scenario highlights the fragility of life, even for civilizations that seem technologically invincible. The Great Filter theory forces us to confront the possibility that the universe is filled with the remnants of civilizations that never made it past these challenges. It suggests that the silence we observe in the cosmos might not be due to a lack of life, but rather the rarity of civilizations that survive long enough to explore the stars. For humanity, this theory is a stark reminder of the precariousness of our existence and the urgent need to address the threats that could prevent us from reaching our full potential. As we ponder the implications of the Great Filter, the next theory will take us even further into the unknown, where the very fabric of reality begins to unravel. Now turning to the next mind-bending theory, let's explore the simulation hypothesis. This idea suggests that our entire universe, including everything we see, feel, and experience, might be nothing more than an incredibly advanced computer simulation created by a highly intelligent civilization. Think of it as a virtual reality so sophisticated that we can't tell it apart from the real thing. But what if this isn't just science fiction? What if it's reality? Philosophers and scientists have debated this theory for decades. One of the most compelling arguments comes from the idea that future civilizations could develop the technology to simulate entire universes. If that's possible, then the odds are high that we're living in one of those simulations rather than the original, base reality. After all, there could be countless simulated worlds, but only one true universe. This line of reasoning makes the simulation hypothesis both fascinating and deeply unsettling. But why is this theory so terrifying? Imagine discovering that everything you've ever known, your memories, your relationships, even your sense of self, could be nothing more than lines of code. The very fabric of reality as we understand it will be called into question. What happens if the simulation glitches or shuts down? Could our existence simply vanish? These questions challenge not only our understanding of the universe but also our place within it. On the other hand, some argue that the simulation hypothesis could explain certain mysteries of the universe, such as why the laws of physics seem so finely tuned to allow life to exist. If we're in a simulation, it's possible that these laws were programmed that way. But this raises another chilling question: who programmed them and why? Are we part of an experiment, a game, or something even more incomprehensible? As we grapple with the implications of the simulation hypothesis, the next theory will take us even deeper into the unknown, where the boundaries of reality blur even further. Now turning to the next spine-chilling theory, let's delve into the dark forest hypothesis. This idea paints the universe as a vast dark forest, where every civilization is like a hunter hiding in the shadows, afraid to make a sound. Why? Because in this forest, the first rule is survival, and revealing yourself could mean inviting destruction. It's a terrifying metaphor for the cosmos, suggesting that silence and secrecy might be the only way to survive in a universe filled with unknown dangers. The dark forest hypothesis stems from the Fermi Paradox, which asks why, in such a vast universe, we haven't encountered any signs of extraterrestrial life. One possible answer is that advanced civilizations are deliberately hiding. They've learned that making contact could be catastrophic. Imagine a scenario where a more advanced civilization sees us as a potential threat or a resource to exploit. The consequences could be devastating: enslavement, annihilation, or worse. This theory suggests that the universe is not a place of cooperation but of ruthless competition, where trust is a luxury no one can afford. But why is this theory so unsettling? It forces us to confront the possibility that our attempts to reach out to the stars through signals like the Arecibo message or the Voyager Golden Record might be a grave mistake. What if our calls into the void are met not with friendship but with hostility? The dark forest hypothesis implies that the universe is a dangerous place, and our survival might depend on staying hidden, silent, and unnoticed. This theory also raises profound questions about the nature of intelligence and civilization. If every advanced society eventually realizes the need to hide, then the universe might be teeming with life, but all of it is too afraid to reveal itself. It's a chilling thought that the cosmos could be alive with civilizations, yet eerily silent, each one watching and waiting but never daring to make contact. As we ponder the implications of the dark forest hypothesis, the next theory will take us even further into the unknown, where the mysteries of the universe grow darker and more enigmatic. Now turning to a theory that challenges the very fabric of reality, let's explore the Boltzmann brain. Imagine for a moment that somewhere in the vast emptiness of space, a fully formed, self-aware brain could spontaneously come into existence. Not as part of a living being, but as a random, fleeting product of quantum fluctuations. This is the bizarre and unsettling idea at the heart of the Boltzmann brain theory. Named after the physicist Ludwig Boltzmann, This theory suggests that in an infinite universe governed by the laws of probability, even the most unlikely events can and will happen given enough time. In this case, the unlikely event is the formation of a conscious brain, complete with memories and thoughts out of nothing but random particles. It's a concept that turns our understanding of consciousness and existence on its head. But why is this theory so mind-bending? For one, it raises the possibility that everything you think you know, your memories, your sense of self, even the world around you, could be an illusion. What if you're not a human being living on Earth, but a Boltzmann brain floating in the void, imagining an entire reality that doesn't actually exist? It's a thought experiment that forces us to question the nature of reality itself. The implications are staggering. If Boltzmann brains are possible, then they might be far more common than actual living beings in the universe. After all, creating a single brain is far simpler than creating an entire planet, a solar system, or a galaxy. This leads to a chilling conclusion. The universe might be filled with countless fleeting, self-aware entities, each experiencing a brief moment of consciousness before dissolving back into chaos. What makes this theory even more unsettling is its connection to the concept of entropy, the measure of disorder in the universe. Boltzmann originally proposed his ideas to explain why we observe order in a universe that tends toward chaos. But the Boltzmann brain theory takes this a step further, suggesting that our perception of order might itself be a random accident, a fleeting moment of coherence in an otherwise chaotic cosmos. As we grapple with the implications of the Boltzmann brain, the next theory will take us even deeper into the mysteries of the universe, where the boundaries of reality and imagination blur even further. Now turning to a theory that stretches the boundaries of imagination, let's dive into the multiverse theory. Imagine, if you will, that our universe is not alone. Instead, it's just one of an infinite number of parallel universes, each with its own unique set of physical laws, realities, and possibilities. This is the mind-bending concept at the heart of the multiverse theory, and it's as fascinating as it is terrifying. The idea of a multiverse suggests that every decision, every event, and every moment in our universe could spawn an entirely new reality. In one universe, you might be a world-famous scientist. In another, you might never have been born at all. Some universes could be nearly identical to ours with only minor differences, while others might be so alien that they defy comprehension. The possibilities are endless, and that's what makes this theory so unsettling. But why is the multiverse theory so terrifying? For one, it raises the possibility that there are universes where life as we know it is impossible. Imagine a universe where the laws of physics are so different that stars can't form, planets can't exist, and life has no chance of emerging. These barren, lifeless realities could be far more common than universes like ours where life thrives. It's a sobering thought that our existence might be the exception, not the rule. Even more chilling is the idea that there could be universes where alternate versions of ourselves exist. These doppelgangers might live lives that are eerily similar to ours, or they could be completely different, shaped by choices we never made or events that never happened in our timeline. What if there's a version of you out there who made a single, fateful decision that changed everything? The thought of these alternate selves raises profound questions about identity, free will, and the nature of reality itself. The multiverse theory also challenges our understanding of the universe's origins. If there are infinite universes, each with its own beginning and end, what does that mean for the concept of a single, unified cosmos? Are we just one tiny bubble in an endless sea of realities, each one expanding, collapsing, or evolving in its own way? The sheer scale of this idea is enough to make anyone feel small and insignificant. As we ponder the implications of the multiverse theory, the next theory will take us even further into the unknown, where the very fabric of space and time is at risk of unraveling. Now turning to a theory that could spell the end of everything we know, let's explore the chilling concept of vacuum decay. Imagine a scenario where the very fabric of space and time is not as stable as it seems. According to this theory, our universe exists in a state called a false vacuum, a temporary, unstable condition that could collapse at any moment. If this collapse were to happen, it would trigger the formation of a bubble of true vacuum, a state of lower energy that would spread outward at the speed of light, obliterating everything in its path. This bubble of true vacuum would rewrite the fundamental laws of physics as it expands. Atoms, molecules, and even the forces that hold the universe together would cease to function as they do now. Stars, planets, and life itself would be erased in an instant, replaced by a new reality governed by entirely different rules. The universe as we know it would simply vanish, leaving behind a cold, lifeless void. What makes vacuum decay so terrifying is its inevitability and unpredictability. Scientists believe that this event could happen at any moment without warning, and there would be no way to stop it. One moment, everything would be normal, and the next, the universe would be gone. The sheer scale of this destruction is almost impossible to comprehend, as it would affect not just our planet or solar system, but the entire cosmos. Even more unsettling is the idea that this process could already be underway somewhere in the universe. A bubble of true vacuum could have formed billions of light years away, and we wouldn't know until it reached us. By then, it would be too late. The thought that the universe could end in an instant without any warning or chance of survival is one of the most terrifying possibilities in physics. As we grapple with the implications of vacuum decay, the next theory will take us even deeper into the mysteries of the cosmos, where the very information that defines reality could be lost forever. Now turning to a mystery that defies our understanding of the universe, let's delve into the black hole information paradox. At the heart of this theory lies a question that has puzzled scientists for decades. What happens to information that falls into a black hole? According to the laws of quantum mechanics, information cannot be destroyed. It can only be transformed or rearranged. But black holes, with their immense gravitational pull, seem to break this fundamental rule. When matter is pulled into a black hole, it is crushed into an infinitely dense point known as a singularity. At this point, all the information about the matter, its composition, structure, and history appears to vanish. This creates a paradox as it contradicts the principle that information must be conserved. If information is truly lost, it would mean that the laws of physics as we know them are incomplete or fundamentally flawed. One proposed solution to this paradox is the idea of Hawking radiation, named after the renowned physicist Stephen Hawking. As black holes emit radiation over time, they slowly lose mass and eventually evaporate. Some scientists suggest that the information swallowed by the black hole could be encoded in this radiation, preserving it in some form. However, this raises another question. How can information that was seemingly destroyed be recovered from radiation that appears random and chaotic? The implications of this paradox are profound. If information can indeed be lost forever, it would challenge our understanding of reality itself. The laws of physics which we rely on to explain the universe would need to be rewritten. This uncertainty has led to intense debates among physicists, with some proposing radical new theories, such as the idea that black holes might not destroy information but instead store it in a hidden dimension or on their event horizons. What makes the black hole information paradox so unsettling is its potential to unravel the very fabric of our understanding of the cosmos. It forces us to confront the possibility that there are aspects of the universe that we may never fully comprehend. As we ponder this mystery, the next theory will take us even further into the unknown, where the nature of reality itself may be nothing more than a projection. Now turning to a theory that could rewrite the fate of everything we know, let's explore the concept of the false vacuum. Imagine our universe as a bubble floating in a vast cosmic ocean. This bubble, according to the false vacuum theory, exists in a state that scientists call metastable, meaning it's stable for now but not permanently. It's like balancing a pencil on its tip. It might stay upright for a while, but the slightest nudge could send it tumbling. In this case, the nudge could be a random quantum fluctuation, a tiny shift in energy that occurs naturally in the fabric of space. If such a fluctuation were to happen, it could trigger a catastrophic event, the collapse of our universe into a lower energy state. This collapse wouldn't be slow or gradual. It would spread at the speed of light, transforming everything in its path. Stars, planets, galaxies, and even the fundamental particles that make up matter would be obliterated in an instant. What makes this theory so terrifying is its unpredictability. It could happen at any moment without warning, and there would be no way to stop it. The laws of physics as we know them would cease to exist, replaced by a new set of rules in this lower energy state. Life as we understand it would be impossible. Scientists describe this event as a phase transition, similar to how water turns to ice but on a cosmic scale. The difference is that while water freezing is harmless, a universe collapsing into a lower energy state would be the ultimate end of everything. The false vacuum theory forces us to confront the fragility of our existence. It reminds us that the universe, for all its vastness and complexity, might be far more precarious than we realize. As we grapple with this unsettling possibility, the next theory will take us even deeper into the mysteries of the cosmos, where the very nature of reality may be at stake. Now turning to a theory that challenges our very understanding of life and death, let's delve into the concept of quantum immortality. This idea stems from the many worlds interpretation of quantum mechanics, which suggests that every possible outcome of a quantum event actually occurs, but in separate, branching universes. In simpler terms, every decision, every random event creates a new universe where each possible result plays out. Here's where it gets mind-bending. If this interpretation is correct, then your consciousness could never truly experience death. Why? Because in at least one of these branching universes, you would always survive, no matter how unlikely the odds. Imagine you're in a life-threatening situation, let's say a car accident. In one universe, the accident might be fatal, but in another, you miraculously survive. According to quantum immortality, your consciousness would continue in the universe where you live, while the version of you in the other universe ceases to exist. This theory raises profound questions about the nature of reality and our perception of it. If consciousness is tied to the universe where survival is possible, does that mean we're all, in a sense, immortal? And what does this imply about the countless versions of ourselves that might have perished in other timelines? The implications are both fascinating and unsettling. On one hand, it offers a strange kind of comfort, suggesting that, from your perspective, you might never truly die. On the other hand, it forces us to confront the idea that our reality is just one of an infinite number of possibilities, each with its own version of events. It challenges our understanding of life, death, and the very fabric of existence. As we ponder the eerie possibilities of quantum immortality, the next theory will take us even further into the unknown, where the boundaries of reality itself begin to blur. Now turning to a theory that questions the fate of advanced civilizations, let's explore the Dyson dilemma. This concept revolves around the idea that highly advanced civilizations could harness the energy of entire stars by constructing massive structures known as Dyson spheres. These hypothetical megastructures would encircle a star, capturing its energy output to power unimaginable technological feats. The dilemma arises from a simple yet unsettling observation. If such civilizations exist, why haven't we detected any evidence of these colossal energy-harvesting structures? The absence of Dyson spheres in our observations of the cosmos raises chilling possibilities. One explanation is that advanced civilizations may have self-destructed before reaching the technological capability to build such megastructures. Whether through war, environmental collapse, or other catastrophic events, they might have wiped themselves out, leaving no trace of their existence. Another terrifying possibility is that these civilizations were destroyed by external forces. Perhaps they encountered a more advanced and hostile species, or fell victim to cosmic events like gamma-ray bursts or rogue black holes. This theory suggests that the universe might be a perilous place, where the rise and fall of civilizations is a common yet tragic occurrence. The Dyson dilemma forces us to confront the fragility of technological progress and the potential dangers that lie ahead for humanity. If advanced civilizations are so rare or short-lived, what does that mean for our own future? Are we destined to follow the same path, or can we learn from the silence of the stars and avoid a similar fate? As we grapple with these unsettling questions, the next theory will take us deeper into the mysteries of the cosmos, where the very fabric of reality may hold even more terrifying secrets. Now turning to a theory that reminds us just how precarious our place in the universe truly is, let's explore the rogue planet threat. Imagine a massive, wandering planet, untethered to any star, drifting silently through the void of space. These rogue planets, often ejected from their original solar systems due to gravitational chaos, could one day enter our own. The consequences of such an event would be nothing short of catastrophic. If a rogue planet were to pass through our solar system, its immense gravitational pull could disrupt the delicate balance of orbits that keep our planets in place. Earth could be flung out of its stable path, either hurled into the freezing depths of space or sent spiraling toward the sun. Even a near miss could trigger devastating effects, such as destabilizing the asteroid belt and sending a barrage of space rocks hurtling toward Earth. But the threat doesn't end there. A direct collision with a rogue planet would be an extinction-level event, obliterating all life on Earth in an instant. The sheer scale of such a disaster is almost unimaginable, yet it's a possibility that underscores the fragility of our existence. What makes this theory even more unsettling is the fact that rogue planets are nearly invisible. Without a star to illuminate them, they drift through the darkness of space undetected until it's too late. This means we might not even see the threat coming until it's already upon us. The rogue planet threat serves as a stark reminder that the universe is a chaotic and unpredictable place. It challenges our sense of security and forces us to confront the reality that, despite all our advancements, we are still at the mercy of cosmic forces beyond our control. As we ponder the fragility of our existence, the next theory will take us even deeper into the mysteries of the cosmos, where the very nature of time and space may hold even more terrifying secrets. Now turning to a phenomenon that could erase life on Earth in the blink of an eye, let's delve into the gamma-ray burst apocalypse. Gamma-ray bursts are among the most powerful explosions in the universe, releasing more energy in a few seconds than our sun will emit in its entire lifetime. These bursts are thought to occur when massive stars collapse into black holes or when neutron stars collide, sending out beams of intense radiation across vast distances. If a gamma-ray burst were to occur within a few thousand light-years of Earth, the consequences would be catastrophic. The burst would bombard our planet with high-energy radiation, stripping away the ozone layer that protects us from the sun's harmful ultraviolet rays. Without this protective shield, Earth's surface would be exposed to deadly levels of radiation, leading to mass extinctions of plants and animals. The sudden influx of energy could also trigger chemical reactions in the atmosphere, producing toxic compounds like nitrogen dioxide, which would further poison the environment. What makes this scenario even more chilling is the speed at which it would unfold. A gamma-ray burst would reach Earth without warning, giving us no time to prepare or react. In an instant, the sky would light up with an otherworldly glow, and within moments the damage would be done. Entire ecosystems could collapse, and humanity would face an existential threat unlike anything we've ever encountered. Yet there is a small silver lining. gamma-ray bursts are incredibly rare events, and the likelihood of one occurring close enough to Earth to cause such devastation is extremely low. However, the fact that it's even possible serves as a sobering reminder of the universe's capacity for destruction. It forces us to confront the reality that, despite our technological advancements, we are still vulnerable to forces far beyond our control. As we grapple with the terrifying implications of gamma-ray bursts, the next theory will take us even further into the unknown, where the very stars we rely on for light and warmth could hold secrets far more sinister than we ever imagined. Now turning to a cosmic phenomenon that blurs the line between life and death, let's explore the chilling concept of the zombie star. Imagine a star that has reached the end of its life, collapsing under its own gravity and seemingly fading into the void. But instead of disappearing forever, it reignites, rising from its own ashes like a cosmic phoenix. This is the eerie reality of a zombie star, a celestial object that defies our understanding of stellar life cycles. When a massive star exhausts its nuclear fuel, it often explodes in a supernova, leaving behind a dense core known as a neutron star or, in some cases, a black hole. However, in rare instances, the remnants of the star can reignite, pulling in surrounding material and undergoing a violent rebirth. This process, known as a recurrent nova, can release an enormous amount of energy, sending shockwaves through space and potentially wreaking havoc on any nearby planets. The implications for planets orbiting a zombie star are nothing short of catastrophic. The sudden burst of energy could strip away atmospheres, vaporize oceans, and obliterate any form of life that might exist. Even planets at a safe distance could face long-term consequences, such as increased radiation levels or destabilized orbits. The unpredictability of these events makes them even more terrifying. There's no way to predict when or if a dead star might suddenly come back to life. What makes the zombie star phenomenon both fascinating and unsettling is its defiance of the natural order. Stars are supposed to follow a predictable life cycle, but these cosmic anomalies challenge that notion, reminding us that the universe is full of surprises. They force us to reconsider what we know about stellar evolution and the delicate balance that allows life to exist in the cosmos. As we ponder the mysteries of zombie stars, the next theory will take us deeper into the shadows of space, where a hidden companion to our Sun could hold the key to some of Earth's most catastrophic events. Now turning to a theory that could rewrite our understanding of the solar system, let's delve into the Nemesis star hypothesis. This chilling idea suggests that our Sun might not be alone. It could have a dark, distant companion, a star so faint and elusive that we've yet to detect it directly. Known as Nemesis, this hypothetical star is theorized to orbit the Sun at a great distance, completing a full cycle every 26 million years or so. But what makes this theory so unsettling is its potential impact on Earth. According to the hypothesis, Nemesis's gravitational influence could periodically disturb the Oort cloud, a vast reservoir of icy bodies at the edge of our solar system. As Nemesis swings closer, it could send a barrage of comets hurtling toward the inner solar system, some of which might collide with Earth. This could explain the apparent pattern of mass extinctions in Earth's history, such as the one that wiped out the dinosaurs 66 million years ago. The idea that a hidden star could be responsible for such catastrophic events is both fascinating and deeply unsettling. But is there any evidence to support this theory? Some scientists point to the cyclical nature of mass extinctions and the potential for a distant gravitational influence as clues. However, others argue that the evidence is circumstantial at best. Modern astronomical surveys have yet to detect a star like Nemesis, and the vast distances involved make it difficult to confirm its existence. Still, the possibility remains, and the implications are profound. If Nemesis exists, it could mean that Earth is periodically subjected to devastating comet impacts, with little warning or ability to prevent them. What makes the Nemesis star hypothesis so terrifying is the idea that our planet's fate could be tied to a cosmic dance we can't even see. It challenges our sense of security and reminds us of the fragility of life in the universe. As we continue to search the skies for answers, the question remains, is Nemesis out there, silently waiting to unleash chaos once again? With this haunting possibility in mind, our next theory will take us even further into the unknown, exploring the mind-bending concept of quantum immortality and what it means for our understanding of life, death, and reality itself. Now turning to a theory that challenges our very understanding of life and death, let's explore the mind-bending concept of quantum suicide. This idea stems from the many worlds interpretation of quantum mechanics, which suggests that every possible outcome of a quantum event actually occurs, each in its own separate universe. But what happens when this theory is applied to the concept of death? The result is a chilling paradox that forces us to reconsider the nature of existence itself. According to the quantum suicide thought experiment, an observer can never experience their own death. Here's how it works. Imagine a scenario where a person is subjected to a quantum event that has a 50% chance of killing them, such as a gun triggered by the spin of a particle. In one universe, the gun fires and the person dies, but in another universe, the gun doesn't fire and the person survives. From the perspective of the observer, they will always find themselves in the universe where they continue to live, no matter how many times the experiment is repeated. In other words, their consciousness will always follow the path where they survive, creating the illusion of immortality. This theory raises profound philosophical and scientific questions. If consciousness is tied to the universe where survival is guaranteed, does that mean death is an illusion? Or does it suggest that our perception of reality is fundamentally flawed? The implications are both fascinating and unsettling. On one hand, it offers a strange kind of comfort, the idea that, from our own perspective, we might never truly die. On the other hand, it forces us to confront the possibility that our understanding of life, death, and reality is far more complex than we ever imagined. What makes quantum suicide so terrifying is the way it blurs the line between science and philosophy. It challenges our most basic assumptions about existence and leaves us questioning whether we can ever truly know the nature of reality. As we grapple with these questions, one thing is clear: the universe is far stranger and more mysterious than we could have ever imagined. With this unsettling thought in mind, our next theory will take us even deeper into the unknown as we explore the enigmatic concept of white holes and their potential to rewrite our understanding of space-time. Now turning to a concept that flips our understanding of cosmic phenomena on its head, let's delve into the white hole paradox. Imagine the opposite of a black hole, a region of space-time where nothing can enter, but matter and energy can only escape. This is the essence of a white hole, a theoretical object that defies our conventional understanding of the universe. While black holes are known for their immense gravitational pull, trapping everything, including light, white holes are thought to expel matter and energy outward, creating a cosmic fountain of sorts. The idea of white holes emerges from the equations of general relativity, the same framework that predicts black holes. In theory, a white hole could be the other end of a black hole, connected by a tunnel-like structure known as a wormhole. But here's where things get truly mind-bending. If white holes exist, they could challenge our understanding of space-time itself. For instance, they might offer a glimpse into alternate universes or even different points in time, raising questions about the nature of causality and the flow of time. What makes the white hole paradox so fascinating is its potential to rewrite the rules of physics. If white holes are real, they could provide a way for information and matter to escape from black holes, potentially resolving the infamous black hole information paradox. But this also leads to terrifying implications. If white holes are connected to black holes, could they serve as gateways to other dimensions or timelines? And if so, what happens to the laws of physics as we know them? The very fabric of reality could be at stake. The concept of white holes also forces us to confront the limits of our scientific knowledge. While they remain purely theoretical, their existence would fundamentally alter our understanding of the universe. Are they remnants of the Big Bang, or do they exist in some hidden corner of the cosmos? The answers to these questions could reshape our perception of existence itself. As we ponder the mysteries of white holes, our journey through the cosmos takes us to yet another enigma, the holographic principle, a theory that suggests our universe might be nothing more than a two-dimensional projection. But more on that in the next section. Now turning to a theory that challenges the very nature of our reality, let's explore the holographic principle. Imagine the universe not as the vast three-dimensional expanse we perceive, but as a two-dimensional surface like a hologram projecting the illusion of depth and dimension. This mind-bending idea suggests that everything we see, touch, and experience, from the stars in the sky to the ground beneath our feet, might be nothing more than a projection from a flat, two-dimensional surface. The holographic principle emerges from the study of black holes and the behavior of information at their event horizons. Scientists discovered that the information about objects falling into a black hole isn't lost but is instead encoded on its surface. This led to the radical idea that the entire universe could operate in a similar way, with all the information about our three-dimensional reality stored on a two-dimensional boundary. In other words, the universe might be a cosmic hologram, with the third dimension being an illusion created by the interplay of quantum information. What makes this theory so groundbreaking is its potential to unify two of the most fundamental theories in physics, quantum mechanics and general relativity. By suggesting that the universe is fundamentally two-dimensional, the holographic principle could provide a framework to reconcile these seemingly incompatible theories, offering a deeper understanding of the fabric of reality. But it also raises unsettling questions. If our reality is a projection, what does that mean for our perception of existence? Are we living in a simulated universe, or is there a deeper layer of reality we cannot yet comprehend? The implications of the holographic principle extend beyond physics, touching on philosophy and the nature of consciousness. If the universe is a hologram, then our sense of self, our thoughts, and our experiences might also be part of this grand projection. This theory forces us to confront the possibility that reality is far stranger and more complex than we ever imagined. As we grapple with the idea that our universe might be a two-dimensional hologram, our exploration of the cosmos leads us to yet another terrifying possibility: the Big Rip, a theory that suggests the universe could tear itself apart. But more on that in the next section. Now turning to a theory that paints a chilling picture of the universe's ultimate fate, let's delve into the Big Rip. Imagine a force so powerful that it could tear apart everything in existence: galaxies, stars, planets, and even the very atoms that make up matter. This is the terrifying scenario proposed by the Big Rip theory, which suggests that the expansion of the universe will accelerate to such an extreme degree that it will eventually overcome all forces holding matter together. The Big Rip hinges on the concept of dark energy, a mysterious force driving the accelerated expansion of the universe. While dark energy currently makes up about 68% of the universe's energy content, its behavior remains one of the greatest mysteries in cosmology. If dark energy grows stronger over time, it could reach a point where it overwhelms gravity, electromagnetism, and even the strong nuclear force that binds atomic nuclei. The result, a catastrophic unraveling of the cosmos. In this scenario, the universe's expansion would accelerate so rapidly that galaxies would be torn apart first, followed by star systems, planets, and eventually atoms themselves. Even the fabric of space-time could be ripped apart, leading to a complete and irreversible end of the universe as we know it. The timeline for such an event is uncertain, with some estimates suggesting it could happen in tens of billions of years, while others propose it might occur much sooner. What makes the Big Rip so unsettling is not just the scale of destruction, but the inevitability it implies. Unlike other theories of the universe's end, such as the Big Crunch or heat death, the Big Rip offers no possibility of renewal or continuation. It suggests a final, absolute end, a universe torn to shreds, leaving behind nothing but emptiness. This theory forces us to confront the fragility of existence and the impermanence of everything we hold dear. It challenges our understanding of the universe's destiny and raises profound questions about the nature of reality itself. As we ponder the possibility of the Big Rip, our journey through the cosmos leads us to yet another chilling theory, the alien zoo hypothesis, which suggests that extraterrestrial civilizations might be observing us from the shadows. But more on that in the next section. Now turning to a theory that shifts our perspective on humanity's place in the cosmos, let's explore the alien zoo hypothesis. This chilling idea suggests that advanced extraterrestrial civilizations are fully aware of our existence but choose to remain hidden, observing us from a distance as if we were specimens in a cosmic zoo. The implications of this theory are both fascinating and deeply unsettling, forcing us to reconsider our assumptions about life beyond Earth. The alien zoo hypothesis stems from the Fermi Paradox, which questions why, given the vastness of the universe, we have yet to encounter any signs of intelligent alien life. One possible explanation is that these civilizations are intentionally avoiding contact, perhaps to study us without interference or to protect us from the dangers of advanced technology. In this scenario, Earth becomes a kind of interstellar wildlife preserve with humanity as the main attraction. This theory raises profound questions about our autonomy and purpose. If we are being observed, what are the intentions of these extraterrestrial watchers? Are they benevolent, merely curious, or do they have more sinister motives? The idea that we might be part of a grand experiment or exhibit is both humbling and terrifying, as it suggests that our actions and development are being monitored and possibly influenced. The alien zoo hypothesis also challenges our desire for contact with extraterrestrial life. While many dream of discovering intelligent beings beyond our planet, this theory suggests that such contact might not be in our best interest. It implies that advanced civilizations might view us as too primitive or fragile to handle the knowledge and technology they possess, leading them to keep their distance. What makes this theory particularly unsettling is the possibility that we may never know the truth. If extraterrestrial observers are as advanced as the hypothesis suggests, they could easily remain hidden, leaving us to wonder whether we are truly alone or merely unaware of the cosmic audience watching our every move. This uncertainty forces us to confront the limits of our understanding and the mysteries that lie beyond our reach. As we grapple with the implications of the alien zoo hypothesis, our journey through the cosmos leads us to yet another mind-bending theory, the time loop universe, which suggests that the universe might be stuck in an endless cycle of birth, expansion, and collapse. But more on that in the next section. Now turning to a theory that challenges our very understanding of time and existence, let's delve into the time loop universe. This mind-bending concept suggests that the universe is trapped in an endless cycle of birth, expansion, and collapse, repeating itself over and over in an infinite loop. Imagine a cosmic reset button where everything we know, galaxies, stars, planets, and even life itself, is destined to be born, grow, and then collapse only to begin again. The implications of this theory are staggering. If the universe is truly cyclical, it means that every event, every moment, and every life has already happened countless times before and will happen again in the future. This raises profound questions about free will and the nature of reality. Are we merely replaying a script written by the laws of physics, or is there room for genuine change within each cycle? The idea that history might repeat itself endlessly is both fascinating and deeply unsettling, as it suggests that our struggles, achievements, and even our very existence are part of an infinite loop with no ultimate purpose or escape. What makes the time loop universe theory particularly eerie is the possibility that we might never know we're in a cycle. Each iteration of the universe could be nearly identical to the last, with no memory of previous cycles. This means that even if the universe has been through this process countless times before, we would have no way of knowing. It's a concept that forces us to confront the limits of our understanding and the mysteries of existence itself. This theory also challenges our perception of time. If the universe is cyclical, then time as we know it might not be linear but rather a series of loops, each one a self-contained universe with its own beginning and end. This idea blurs the line between past, present, and future, suggesting that everything that has ever happened or will happen is part of an eternal, repeating pattern. As we grapple with the implications of the time loop universe, we're left to wonder whether our lives and the universe itself have any ultimate meaning, or if we're simply part of an endless cosmic dance. This theory not only reshapes our understanding of the cosmos, but also forces us to question the very nature of our existence. And with that, we move forward to explore yet another unsettling theory, the quantum entanglement mystery, which challenges our understanding of reality itself. Now turning to the quantum entanglement mystery, we enter a realm of physics that defies our everyday understanding of reality. Quantum entanglement is a phenomenon where two particles become linked in such a way that the state of one instantly influences the state of the other, no matter how far apart they are. This connection happens faster than the speed of light, challenging one of the fundamental principles of Einstein's theory of relativity. Imagine two coins spinning in opposite corners of the universe. Flip one, and the other instantly lands on the same side, as if they share a hidden, invisible bond. This bizarre behavior has profound implications for our understanding of the universe. Scientists have long speculated that quantum entanglement could revolutionize communication, allowing for instantaneous information transfer across vast distances. Imagine sending a message to a colony on Mars without any delay, or even communicating with civilizations in distant star systems. The potential for faster-than-light communication could transform technology, space exploration, and even our understanding of time itself. But with this incredible potential comes a darker side. The idea that particles can influence each other instantaneously, regardless of distance, raises unsettling questions about the nature of reality. Could this phenomenon be exploited for surveillance or control on a cosmic scale? What if an advanced civilization has already mastered quantum entanglement and is using it to monitor or manipulate us without our knowledge? The thought of an invisible, instantaneous connection spanning the cosmos is both awe-inspiring and deeply unnerving. Moreover, quantum entanglement challenges our understanding of cause and effect. If two entangled particles can influence each other faster than light, it suggests that the universe operates on principles far stranger than we can currently comprehend. This phenomenon forces us to reconsider the very fabric of reality, blurring the lines between space, time, and the fundamental laws of physics. As we explore the quantum entanglement mystery, we're left to grapple with the implications of a universe where distance and time may not be the barriers we once thought. This theory not only opens up exciting possibilities for the future of science and technology, but also forces us to confront the unsettling idea that the universe may be far more interconnected and far more mysterious than we ever imagined. And with that, we move forward to uncover yet another cosmic enigma, the dark matter enigma, which holds the key to understanding the invisible forces shaping our universe. Now turning to the dark matter enigma, we delve into one of the most perplexing mysteries of the cosmos. Dark matter is an invisible substance that makes up roughly 85% of the universe's total mass. Yet, despite its overwhelming presence, it doesn't emit, absorb, or reflect light, making it completely undetectable by conventional means. Imagine a vast, invisible web stretching across the universe, holding galaxies together and shaping the very structure of reality. Yet we can't see it, touch it, or even directly observe it. Scientists first inferred the existence of dark matter by observing the behavior of galaxies. Stars on the outer edges of galaxies move at speeds that defy the laws of gravity as we understand them. If only the visible matter in galaxies existed, these stars should fly off into space, but they don't. Something unseen, dark matter, must be exerting a gravitational pull, keeping everything in place. This invisible force is the cosmic glue that holds the universe together, yet its true nature remains one of the greatest unsolved puzzles in science. The implications of dark matter are staggering. If we could unlock its secrets, we might finally understand the fundamental forces that govern the cosmos. It could reveal new dimensions, particles, or even entirely new laws of physics. But the fact that we can't see or interact with it raises unsettling questions. What if dark matter isn't just a passive force? What if it interacts with our world in ways we can't yet comprehend? Could it be responsible for unexplained phenomena, or even influence the fate of the universe in ways we can't predict? The search for dark matter has led scientists to build some of the most advanced detectors ever created, buried deep underground to shield them from interference. Yet, despite decades of research, dark matter continues to elude us. This invisible enigma challenges our understanding of the universe, forcing us to confront the possibility that most of reality lies beyond our perception. As we grapple with the dark matter enigma, we're reminded that the universe is far stranger and more mysterious than we ever imagined. This theory not only reshapes our understanding of the cosmos, but also leaves us with a haunting question. What else is out there, hidden in the shadows, waiting to be discovered? And with that, we move forward to explore another cosmic mystery, the strange patterns found in the cosmic microwave background anomalies, which may hold clues to the very origins of the universe. Now turning to the cosmic microwave background anomalies, we uncover another layer of the universe's deepest mysteries. The cosmic microwave background, or CMB, is the faint afterglow of the Big Bang, a snapshot of the universe when it was just 380,000 years old. This ancient light fills the entire cosmos, carrying with it the secrets of the universe's infancy. But within this seemingly uniform glow, scientists have discovered strange patterns, anomalies that defy our expectations and challenge our understanding of the early universe. One of the most puzzling anomalies is the so-called cold spot, a region of the CMB that is significantly colder than its surroundings. This cold spot spans an area of the sky roughly 1 billion light-years across, and its existence has left scientists scratching their heads. Could it be a statistical fluke, a cosmic coincidence, or is it evidence of something far more profound, perhaps a collision with another universe in the multiverse, or a glimpse into a realm of physics beyond our current understanding? Another anomaly lies in the uneven distribution of temperature fluctuations across the CMB. According to the standard model of cosmology, these fluctuations should be random and evenly spread. Yet the CMB shows a peculiar alignment, as if the universe has a preferred direction. This axis of evil, as some scientists have dubbed it, suggests that our understanding of the universe's origins might be incomplete or even fundamentally flawed. These anomalies raise profound questions about the nature of reality. Could they be evidence of a multiverse where our universe is just one of countless others? Might they hint at the existence of unknown forces or dimensions that shaped the cosmos in its earliest moments? Or do they point to a deeper truth about the universe, one that we have yet to grasp? The implications of these anomalies are staggering. If they reveal hidden truths about the early universe, they could rewrite the story of how everything began. They might even challenge our understanding of time, space, and the very fabric of reality. As we continue to study the CMB, we're reminded that the universe is full of surprises, and that even the faintest whispers of ancient light can hold the keys to unlocking its greatest mysteries. With these anomalies in mind, we move forward to explore another mind-bending theory: the possibility that advanced civilizations could thrive within the unimaginable environment of a black hole, harnessing its immense energy for survival. Now turning to the black hole civilization, we venture into one of the most mind-bending and terrifying theories in the realm of space mysteries. Imagine a civilization so advanced that it could not only survive but thrive within the extreme environment of a black hole. At first glance, this idea seems impossible. Black holes are known for their immense gravitational pull, so strong that not even light can escape. Yet, some scientists speculate that within the chaotic depths of a black hole, conditions might exist that could support life, or at least a form of existence far beyond our current understanding. The key to this theory lies in the concept of the ergosphere, a region just outside the event horizon of a rotating black hole. Here, the intense gravitational forces create a zone where energy could theoretically be extracted. An advanced civilization might harness this energy, using it to power their survival in an otherwise hostile environment. This idea challenges our understanding of life, suggesting that it could exist in forms and places we once thought unimaginable. But the implications go even further. If civilizations could thrive inside black holes, it raises the possibility that the universe is teeming with life in ways we cannot yet detect. These civilizations might be hidden from us not by distance, but by the very nature of their existence within the extreme physics of black holes. This theory also forces us to reconsider the limits of technology and the potential for life to adapt to even the most inhospitable conditions. Yet, the idea of a black hole civilization is as terrifying as it is fascinating. The thought of beings living in such a hostile environment where time and space are warped beyond recognition challenges our understanding of reality itself. It suggests that the universe is far stranger and more complex than we ever imagined, and that the boundaries of life and intelligence may extend far beyond what we currently comprehend. As we ponder this theory, we're reminded once again of the vast mysteries that lie within the cosmos. The possibility of black hole civilizations not only expands our imagination, but also deepens our sense of awe and unease about the universe we inhabit. With this in mind, we move forward to explore another unsettling theory, the unresolved paradox of quantum gravity, and how it challenges our understanding of the very fabric of reality. Now turning to the quantum gravity paradox, we delve into one of the most profound and unresolved mysteries in modern physics. At the heart of this paradox lies the clash between two of the most successful theories in science: quantum mechanics, which governs the behavior of the smallest particles, and general relativity, which describes the force of gravity and the structure of the universe on a cosmic scale. While both theories have been incredibly accurate in their respective domains, they seem fundamentally incompatible when it comes to understanding the nature of gravity at the smallest scales. Quantum mechanics tells us that particles like electrons and photons behave in unpredictable, probabilistic ways, existing in multiple states until observed. On the other hand, general relativity paints a smooth, continuous picture of spacetime, where gravity is the result of massive objects warping the fabric of the universe. The problem arises when we try to apply these two frameworks together, particularly in extreme environments like black holes or the moments just after the Big Bang. Here, the rules of quantum mechanics and general relativity seem to break down, leaving scientists with no clear way to describe what happens. This paradox has led to decades of research and speculation, with theories like string theory and loop quantum gravity attempting to bridge the gap. Yet, despite these efforts, a unified theory of quantum gravity remains elusive. The implications of this unresolved mystery are staggering. Without a complete understanding of how gravity operates at the quantum level, we cannot fully explain the origins of the universe, the nature of black holes, or even the ultimate fate of spacetime itself. What makes the quantum gravity paradox so unsettling is the possibility that our current understanding of reality might be incomplete or even fundamentally flawed. It suggests that the universe operates by rules we have yet to uncover, and that the true nature of gravity, and perhaps all of existence, might be far stranger than we can imagine. This theory challenges not only our scientific knowledge but also our philosophical understanding of the cosmos, forcing us to confront the limits of human comprehension. As we grapple with this paradox, we're reminded once again of the vast unknowns that lie at the edges of our understanding. The quantum gravity paradox is not just a scientific challenge, it's a humbling reminder of how much we have yet to discover about the universe. With this in mind, we move forward to explore another mind-bending theory, the concept of eternal inflation, and how it suggests our universe might be just one bubble in an endlessly expanding multiverse. Now turning to the eternal inflation theory, we explore a concept that suggests our universe might be just one of countless bubbles in an endlessly expanding multiverse. This theory builds on the idea of cosmic inflation, which proposes that the universe underwent an exponential expansion in the moments following the Big Bang. But eternal inflation takes this a step further, suggesting that this rapid expansion never truly stopped. Instead, it continues in some regions of space, giving rise to an infinite number of bubble universes, each with its own unique physical laws and properties. Imagine a vast cosmic ocean where each bubble represents a separate universe floating in an infinite sea of spacetime. Some of these bubbles might have conditions similar to our own, with stars, planets, and even life. Others could be entirely alien, governed by laws of physics so different from ours that they defy comprehension. The unsettling part of this theory is the sheer scale of it all. If eternal inflation is true, then our universe is just one tiny speck in an unimaginably vast multiverse where anything and everything might exist. What makes this theory so mind-bending is the implication that reality itself might be far more complex and varied than we ever imagined. It challenges the notion that our universe is unique or special, suggesting instead that it's just one of countless possibilities. This raises profound questions about the nature of existence. Are there other versions of us out there, living in parallel universes with different histories and outcomes? Could there be universes where time flows backward or where gravity doesn't exist? The possibilities are as endless as the multiverse itself. The eternal inflation theory also forces us to confront the limits of our understanding. If the multiverse is real, it means that much of reality lies beyond our ability to observe or comprehend. It's a humbling reminder that, despite all our scientific advancements, we've only scratched the surface of what might be out there. This theory doesn't just expand our view of the cosmos, it shatters it, leaving us with more questions than answers. As we ponder the implications of eternal inflation, we're left with a sense of awe and unease. The idea that our universe is just one bubble in an infinite multiverse is both fascinating and deeply unsettling, challenging everything we thought we knew about reality. With this in mind, we move forward to our final theory, the concept of the end of time itself and how it might reshape our understanding of existence. Now turning to the final and perhaps most unsettling theory on our list, we delve into the concept of the end of time itself. Imagine a reality where time, the very fabric that structures our existence, ceases to exist. This isn't just the end of the universe as we know it, it's the end of the framework that allows events to unfold, memories to form, and life to persist. The idea that time could come to an end is not only mind-bending but also deeply unsettling, as it challenges our most fundamental understanding of reality. One possible scenario for the end of time is the Big Crunch, where the universe, after expanding for billions of years, begins to collapse back in on itself. In this scenario, time would reverse as galaxies, stars, and planets are pulled together into a single, infinitely dense point. The universe would essentially rewind, erasing all that ever was until time itself stops. Another possibility is the Big Rip, where the expansion of the universe accelerates to such an extreme that it tears apart galaxies, stars, and even atoms. In this scenario, time would end not with a collapse, but with a violent, irreversible disintegration of everything. But what does it mean for time to end? Time is more than just a measurement. It's the dimension that allows cause and effect, change and progression. Without time, there is no past, present, or future. There is no growth, no decay, no story. The end of time would mean the end of existence as we understand it, leaving behind a static, unchanging void. It's a concept so alien to our experience that it's almost impossible to fully grasp. What makes this theory so terrifying is its inevitability, at least according to some models of cosmology. Whether through the Big Crunch, the Big Rip, or another cosmic event, the end of time seems like a possible, if not probable, outcome for the universe. It forces us to confront the impermanence of everything, not just our lives or our planet, but the very structure of reality itself. As we reflect on the end of time, we're left with a profound sense of awe and unease. This theory doesn't just challenge our understanding of the universe, it challenges our understanding of existence itself. And with that, we conclude our journey through the 30 most terrifying space theories, each one a reminder of how vast, mysterious, and humbling the cosmos truly is. If these theories left you questioning everything you thought you knew about space, don't forget to like, share, and subscribe for more mind-bending content. Let us know in the comments which theory you found the most unsettling, and stay curious as we continue to explore the mysteries of the universe together. Now turning to the conclusion of our journey through the 30 most terrifying space theories, let's take a moment to reflect on the profound questions these ideas raise about the universe and our place within it. From the Big Crunch to the end of time, each theory challenges our understanding of reality in ways that are both awe-inspiring and deeply unsettling. These concepts force us to confront the fragility of existence, the vastness of the cosmos, and the mysteries that lie beyond our current comprehension. Whether it's the chilling possibility of the Great Filter, the mind-bending implications of the simulation hypothesis, or the existential dread of the Big Rip, these theories remind us that the universe is far stranger and more complex than we can imagine. They push the boundaries of science, philosophy, and even our own imaginations, leaving us with more questions than answers. As we wrap up, we invite you to share your thoughts in the comments below. Which of these theories did you find the most unsettling? Was it the idea of living in a simulated reality, the threat of a rogue planet, or the eerie silence of the Fermi Paradox? Let us know what keeps you up at night, pondering the mysteries of the cosmos. If you enjoyed this deep dive into the terrifying and fascinating world of space theories, don't forget to like, share, and subscribe for more mind-bending content. Hit the notification bell so you never miss an update as we continue to explore the wonders and horrors of the universe together. Stay curious, stay questioning, and remember, the cosmos is full of secrets waiting to be uncovered. Until next time, keep looking